We're live here at Mount Lebanon High. Caterpillarsaurus on the loose. And how do you defeat such a beast? Math. So let's use math to defeat him. So of all the things we know about this Caterpillarsaurus, would you say it's of the species Arithmetici or Geometricis? Why? Right, it's not increasing its leaf consumption by the same amount. It's a percentage, right? It's eating 25% more every day. How do you figure out, first of all, then, what R is if it's eating 25% more? Well, if this is a percent growth problem, you take 100% plus what it's eating. And what do you get? 125%, which equals what as a ratio? 1.25. If it would have been decaying by 25%, we would have subtracted, gotten 75%, and we would have used 0.75. That's a concept from, September of this year. All right? So let's move on. We now know what R is, and it is geometric. So let's come up with a formula that shows us its leaf-eating habits over time, right? This will basically show you how much food is going to be eaten on any given day. All right, so the formula will be U1, which is the starting amount, times R to the n minus 1. This formula is kind of growing on me. Instead of the one with U0, I think I like this one better for geometric because we know U1, except today. We don't know how many he ate the first day. We don't know how many he ate on day 30. What we do know is what? That he's eaten when? In his lifetime. So please understand that there is a difference between U30 and S30. What's U30? Yes, the leaves eaten on the 30th day. What's S30? Right. So if U1 was, I don't know, some amount, and U2 was 25% more, and ... we got all the way down to U3, 30, and it was some other amount, what's the sum of all those? S30, which is 151,677. That's the sum of the first 30 days worth of leaves eaten by the Caterpillarsaurus. This is a ridiculous problem, but let's keep going anyways. Are you ready? So that is my S30. What formula did we learn yesterday for finite, partial, same thing, geometric? Now, what's this part of the formula? That was the infinite geometric that we learned in the last section, right? And that formula that just disappeared in blue was only applicable if R was between -1 and 1 and it was infinite. This formula works for any geometric series as long as you have a stopping value, even the ones where R is a decimal, okay? This formula works for all values of R, all values of R, okay? R could be 1.25, R could be 0.5, R could be -0.3, R can be anything. As long as it's geometric, this formula will work. All right. We know everything in this formula except U1. So we're going to plug in what we know and solve for what we don't know. What we're going to calculate here is how many leaves this beast ate on day 1. This is 151,677. This is our unknown. 1 minus, what's our R? Yes, Yes, 1.25. How many days has it been? 30 days of living with this beast in town. Oh, no. And what's on the bottom? 1 minus 1.25, which does calculate to negative 0.25. All right? So we're going to calculate some stuff here and solve for U1. I'm going to explain the steps, but not record them. I'm not going to show you the answers we get. You calculate this, and it comes out to be negative 0.25. You multiply both sides by that number to get an answer on the left. You would have U1 times this equals that number. All right? Then you would divide both sides by this. Yes. You divide both sides by this 1 minus 1.25 to the 30th. And you should get the first term, 47. He eats 47 leaves on day 1. Great. We're not even close to being done with the problem yet, right? Because it didn't ask us how many leaves he ate on day 1. It asked us how many leaves he ate the next day. Well, what day is that? Day 31. So we go to our formula, which was, I can find how many leaves he eats on any day by taking U1 times R to the n minus 1. I now know everything that I need to know to find out how many leaves he ate on day 31. We know U1, we know R, and the exponent would be 31 minus 1, 30. And that comes out to be 37,966 leaves consumed by Caterpillarsaurus on day 31. How that helps us defeat him, I have no idea.